Do you know how the pilots know the speed at which the aircraft is flying, or the altitude, or the rate of climb or rate of descent that the aircraft is flying at, or even the status of various aircraft systems? In this video today, we are going to be looking at aircraft instruments. Welcome to the channel, and I hope you'll enjoy the video. Aircraft instruments. What are aircraft instruments, and what do they do, and what are the types of aircraft instruments? Aircraft instruments are used to show, or are used by the pilots to monitor the flight of an aircraft. To monitor the flight, to monitor engine parameters, and also to monitor the status of various systems that are found on an aircraft. That is the function of aircraft instruments. There are some types of aircraft instruments. We look at three. We have three types of aircraft instruments. We have flight instruments, we have engine instruments, and we have system instruments. In today's video, we're going to be looking at flight instruments. In flight instruments, we have gyroscopic instruments and we have pitot static instruments. In this video, we're going to be focused particularly on the pitot static instruments. For the pitot static instruments, these instruments are instruments that uses air data. In some configuration, you find that air that comes, the air information, the air that is tapped from the pitot probes and static ports goes directly to the instruments. But in some other configuration, you get that from the pitot tubes, the air goes to the air data computers, and from the air data computers, then the air is taken to the instruments. So what is a pitot probe, and how is it, where is it installed on on an aircraft, and how does it work? In this picture here, we have two pictures here. This picture, here you can see a pitot tube as installed on an aircraft. And on most aircraft, even large aircraft, you find the pitot tubes on the sides of the aircraft. Sometimes you can find one here and two on the right side, or you can find two on both sides, depending on the configuration of an aircraft. On this one, we have a pitot tube, one on the left, and we have two on the right. So this is the configuration, or this is how the pitot tube is installed on an aircraft. And now this is a closer picture of a pitot tube, and I will try to explain what happens. Now, a pitot tube has a pitot port here that as the aircraft moves forward, air goes in, and this is ram pressure that is used to mesh to be indicated on an aircraft. The ram pressure comes from this pitot port, and around the neck of the pitot you have some small ports which are called static ports. In some aircraft configuration, you have a separate pitot tube and static ports on different surface, but on most aircraft they are combined on the pitot tube. Like this one here, it's a combined configuration where you have a ram port for the pitot pressure and the static ports for the static pressure. At this other end, the root of the pitot tube where it is installed on an aircraft, we have some connections here. And the first connection is for the pitot pressure. This line, the pitot pressure line, comes to this first connection. In this particular example, we have two static pressure lines. In some other configuration, we only have one. So this is something you should note. It is not the same on different aircrafts. On this one that we are going to use, on this pitot tube, in this example, we have two static ports. So one goes to the captain's side, and the other one goes to the first officer's instrument side. And finally, the last port is for anti-icing. Due to high altitude flying and ice accumulation in the pitot tube, which may even clog the pitot ports, there is need to have anti-icing to prevent ice formation in the pitot tube. So the third port, most of the time, it's an electrical connector, is used for anti-icing of the pitot, anti-icing and de-icing of the pitot tube. Next, we're going to be looking at the pitot static instruments that, remember we've said in this video we're going to be focused on the pitot static instruments. And the pitot static instruments, those are the instruments that are used, that uses air data that we're going to be focusing on are these three instruments, as you can see on the video. We have one, the airspeed indicator, two, the altimeter, and finally the vertical speed indicator. I will go through each and every one of them, and then I will try to show how they work together and how they are linked into the system. So I'll start with the airspeed indicator. The airspeed indicator measures differential pressure. Basically, it shows the speed of an aircraft by measuring the pressure difference between the ram pressure that is the pitot pressure, and the static pressure. The static pressure is the pressure of the air surrounding the aircraft, basically the ambient air surrounding the aircraft. And the pitot pressure is the pressure as the aircraft moves forward, the pressure that rams into the pitot tube. You remember from the previous diagram here that I showed, from this spot, as the aircraft moves forward, there's ram pressure that goes inside this tube. So this pitot pressure is the one that is measured against the static pressure, which is the ambient air. The difference with this pressure is where the airspeed is derived. If the difference is large between the two, then the airspeed is high. If the difference is low, the airspeed is low. So how does the airspeed indicator measure this pressure? As the airspeed indicator has two ports, one for the static pressure and one for the pitot pressure. The one for the pitot pressure goes into a diaphragm that is inside the instrument casing, and the static one goes into the instrument casing. Now, as the aircraft speed increases, the pitot pressure increases and causing the diaphragm to expand. And as the diaphragm expands, the pointer on the indicator shows an increase in aircraft speed. So that is basically how the instrument works. The instrument is calibrated in knots. The instrument is calibrated in knots, but on some older aircraft you have those that are calibrated in miles per hour. So that is the airspeed indicator. Now the altimeter shows the aircraft altitude. It is calibrated in feet, and an altimeter measures static pressure. Basically, it's the atmospheric pressure at the given level where the aircraft is flying. The atmospheric pressure at that level is what the altimeter measures. And it only has one tube or one pipe that brings the static pressure into the instrument. Inside the instrument, we have a capsule that is it is totally sealed. It's a metal capsule that is sealed, and the capsule is inside the casing, which is connected to the static port. Now, as the aircraft climbs, the pressure decreases, the ambient pressure decreases. As the pressure decreases, the capsule expands, and the expansion of the capsule, due to decrease in the pressure inside the casing, causes the altimeter to indicate a rise in altitude. And as the aircraft descends, the static pressure inside the case increases, and as it increases, the capsule is compressed, and as it compresses, it indicates a decrease in the altitude of an aircraft. The next instrument that we are going to be looking at is the vertical speed indicator. The vertical speed indicator indicates the rate of climb or the rate of descent of an aircraft. It is calibrated in feet per minute. It has feet per minute from 0. It has an increasing feet per minute, and also going down, decreasing, to indicate a rate of descent and rate of climb. The vertical speed indicator also measures the static, also uses the static pressure, which is the ambient pressure, and it measures the change in the static pressure. As the aircraft climbs, as it goes through different levels of different altitude or different pressure level, the pressure inside the casing of the vertical speed indicator increases or decreases, and this change causes a change, an indication difference or an indication change on the vertical speed indicator, and as a result this indicates a climb or a descent. As the pressure inside the casing increases, the pointer indicates the rate of descent, and as the pressure inside the casing decreases, the indicator increases a rate, the indicator indicates a rate of climb on the display. We are going to be looking at how these instruments work together and how they are connected together. So this is the Pitot tube. Remember from the previous diagram we saw a Pitot tube, and we saw one that has a pitot pressure and the static pressure combined, but in this configuration they are separate. This is the Pitot tube that measures the pitot pressure, and we have static ports here that measures the ambient pressure or the static pressure surrounding the aircraft. Note now, these are the three instruments we've discussed: the airspeed indicator, the vertical speed indicator, and the altimeter. Remember, for the airspeed indicator, we said it uses differential pressure, and as such it is fed with two sources, that is static pressure and pitot pressure. So this is the line that brings pitot pressure to the airspeed indicator, and this is the line that brings static pressure to the indicator. It is the only instruments from the three that we have discussed that uses differential pressure. And vertical speed indicator, like we've mentioned before, it indicates the rate of climb and rate of descent, and it only uses static pressure. As you can see from this diagram, it only uses pressure from the static ports to indicate the rate of climb and descent. The same with the altimeter. The altimeter also measures static pressure to indicate the level or the altitude above sea level at which the aircraft is flying. So it also uses static ports. The only instrument from the three that we've discussed that uses both static pressure and pitot pressure is the airspeed indicator, because it measures differential pressure. You can see this, we have a pitot heat. Remember I showed you the fourth connector on the Pitot tube that we saw previously is used for anti-icing. So this is what the Pitot heat, where the Pitot heat goes, and it is used for anti-icing. We have a drain opening to drain all moisture that may accumulate inside the Pitot tube. And on some aircraft we have an alternate static source. Should this static port be clogged, we have an alternate source that is used to provide static pressure to the instruments. In the next picture, we're going to see how these instruments are arranged in a cockpit. So we have two diagrams here, and I will start with the one on the left. This shows these instruments, as you can see in this diagram, are called the basic six, or sometimes they are called the six-pack. This is the basic instrument needed for or found on an aircraft, and are used during flight. They are duplicated on the captain's side and the first officer's side. So this is the airspeed indicator, as we have seen we've previously discussed. This is the altimeter on the right, and the vertical speed indicator is the one that is underneath the altimeter. So these are the three pitot-static instruments that we discussed. Remember I told you for flight instruments we have pitot-static and gyroscopic. These three here are gyroscopic. We have the attitude direction indicator. We have the horizontal situation indicator that shows the direction of the aircraft in relation to magnetic north. And then we have a turn coordinator, or on some aircraft it's a turn and slip indicator that basically shows if the rate of turn and roll is properly coordinated or if it's not coordinated, because if it's properly coordinated, the aircraft will slip or skid depending on which rate is higher, if the yaw is higher than the roll, or if the roll is higher than the yaw. So the attitude direction indicator shows the attitude of the aircraft, the pitch altitude or the roll altitude, the attitude of the aircraft, sorry. And the horizontal situation shows the direction or the heading of the aircraft in relation to north, magnetic north. I've told you about the turn coordinator, and these other three, vertical speed and altimeter and the airspeed, are the instruments that we've already discussed. Now this is the instruments found in a conventional aircraft, the conventional aircraft instruments. Now in modern aircrafts, these instruments are combined into one display, which is called a primary flight display. And this is just a sample of a primary flight display and how it looks like. So this here is the attitude direction indicator on a modern aircraft. This one is the airspeed indicator, and it shows the airspeed of the aircraft. This one is the altimeter that shows the altitude of an aircraft on a modern aircraft. And this one is basically sort of a compass, and it shows the horizontal situation of an aircraft. Basically, it shows the heading of the aircraft. And at the right here, we can see a vertical speed indicator that shows the rate of climb and the rate of descent of an aircraft as found on a modern aircraft. So this is what we had for you today in this video. I hope you've enjoyed and understood the video. If you have any question, if you need any clarification, you can always write on the comment, and I will get back to you. So I hope you enjoyed the video. Thank you for tuning in. If you haven't subscribed, we'll always remind you to subscribe to the channel and to turn on notifications so that you always get notification whenever we post new video. Thank you and bye-bye.